Good morning. So this is my 7th lecture on Signals and Systems course. Today I am going to discuss about unit step and unit delta functions. These are the elementary functions, or you can call it as signals. So here I will be interchangeably using the words signals and functions. Both are same. Both are time functions, means time functions. Signals also continuous time signals. And of course, discrete time signals are also there. So the independent variable is only time. And I'm going to discuss about these two elementary signals, that is unit step function and unit delta function or signals. And the sources for this lecture is these two textbooks, B.P. Lati and Simon Higgins. So let us start about the unit step function. So here the unit step function is given by the notation u of t, by the variable u of t, or function u of t. It is equal to unity when time is equal to greater than or equal to 0, and it is 0 before t equal to 0, that is t less than 0. And pictorially it is represented in this way as a step function. There is a step at t equal to 0. Okay, this is the function. Now this exists when t equal to greater than or equal to 0. Before t equal to 0, it doesn't exist. And this is the basic function because this is useful to describe several other functions. For example, you take this exponential function. I have u to the power of minus t u of t, and this is representing, basically u of t is again the time function which is starting at t equal to 0, but the basic function is e to the power of minus at here. Given function is e to the power of minus at multiplied by this. Okay, so here this can be expressed as multiplication of two functions. See, for example, if I extend this given function, exponential function, it goes on like this. Okay, so what I am doing, I have taken e to the power of x, e to the power of minus at function. Now I am taking a step function u of t below that. Then I am multiplying this function with this given function. Okay, so this given function I am multiplying. So what is happening here? It is equal to 0. Here it is equal to 0. So 0 multiplied by this part of the signal will become 0. And this part, it is always existing unity till minus infinity it is, plus infinity it is there. So when I multiply, I have the signal which is time limited between 0 and plus infinite. Okay, so that means the given function is multiplied with the unit step function. So what is the other way of telling this? Other way of telling this is, I can also write like this. Let us say x of t equal to e to the power of minus at for t greater than or equal to 0, 0 elsewhere. Elsewhere means t equal to less than 0. Okay, so one way of expressing this function is this. If I want to avoid all these expressions, I can simply write e to the power of minus at multiplied by u of t. Okay, so this is the compact representation of the signal. So u of t function, by using the unit step function u of t, you can specify the time interval of the existence of the signal. So that is the purpose of unit step function basically. Okay, now I am given a pulse here between 2 to 4 seconds. There is a pulse whose amplitude is unity. Okay, so let us express this in terms of unit step functions. Okay, so let us take a unit step function starting at t equal to 2. Okay, so this is nothing but a unit step function u of t delayed by 2 units of time, 2 seconds, 2 units of time. Okay, now take another unit step function which is delayed by minus 4. So this is what is delayed by minus 4 at a t equal to 4. T equal to 4. The step function is starting, but its polarity is minus 1. Its polarity is minus 1. So what is that I am doing now? I have taken 2 step functions. One which is starting at t equal to 0. Other one which is starting at t equal to 4. So this part, whatever is unit step function starting at 4 units can be represented by u of t minus 4, delayed by 4 units. Okay, but of course with sign inversion is also there. Now you add these signals. This is first one. This is second one. 2 step functions you add 1 plus 2. If I write 1 plus 2, so this is what is the expression for this, because there is a minus here, minus because of minus signature, minus sign, I will get the minus of u of t minus 4. Okay, so this is first function, second function, it is f of t. Okay, so this is expression wise. Pictorially, when I see what is happening, this area is a negative area. When I add these two, and this area up to this part, it is positive area. It is positive area. This is positive area. This is negative area. Because this is extended up to infinite and infinite. So there is no time limit here. So these two areas, they exactly cancel with each other. This will go, the area under this, in the shaded region, it will be equal to 0. So what is happening? The remaining portion is only between 2 to 4, a pulse kind of thing. So that is nothing but this pulse. Okay. So right side this pulse, all the area, whatever I have shown in the shaded form here, that will become 0 here. And before this, anyway, this is 0 is there. So this is 0. So a pulse can be, a finite width pulse can be expressed as the summation of 2 step functions. Okay, one positive step function, other one is negative step function. Okay, so that is what is the synthesis. That means I have synthesized this pulse by 2 unit step functions. Take another signal here. I am showing another example here. I have a triangle signal function or signal like this, and it has a positive slope between 0 and 2. Between 0 and 2, it has positive slope. Between 2 and 3, it has a negative slope. It is a concatenation of 2 linear segments, 2 straight lines. Okay, so let us call the first straight line as F1, second straight line as F2. I have separated these two and I have shown here, this is F1, positive slope straight line, and this is straight line with negative slope. That is nothing but F2, F1. These are the, from this I have separated this into 2 parts, F1 and F2. Now let us represent the F1 and F2 separately. This is F1 I am showing here. I can assume that I can extend this straight line like this. So this is actually, here it is 2 is there, and it is passing through origin. So there is no intercept here, y-intercept is not there. So I can say that this is a straight line which is passing through origin, which has a unity slope. So this must be pi by 4 radians. Okay, pi by 4 radians. So tan pi by 4 is unity. The slope of this function is unity. So I am writing here it as, see, t, because independent variable is t. slope is unity. So slope into m into t. So this f1, I can write this as f1 of t equal to slope m multiplied by t plus c. Okay, because this f of 1 is on the y-axis. So it is mt plus c, because t equal to 0 anyway, because it is passing through the origin, and m equal to unity. So this is nothing but t. The function is nothing but t. So the infinite straight line, this is infinite straight line, whose slope is 45 degrees. I mean slope angle, and it is represented by t. Okay. Now what I am doing, I want to get this triangle. If I have to get this triangle, what I have to do? I have to take a pulse like this, multiply with this. So I am taking a pulse here, multiply with this infinite lines, infinite line, straight line. Okay, when I multiply, I have to multiply with a pulse so that I will get this triangle. How I represent this one? This is 0 here, 2 here. So as I explained you in the previous slide, this is a combination of u of t, positive step function, minus u of t minus 2. Okay, so this part you know already. So this part you know already. So this is nothing but your pulse. Okay, now you are multiplying this pulse with this t function, with this t multiplied by this pulse. Okay, t is nothing but the equation for the straight line. Now after multiplication, what is this one? This is nothing but my f1. So f1 equal to pulse multiplied by straight line t. Okay, so this is the expression for the first triangle. Okay, so what is the second triangle? Second triangle is this one with negative slope between 2 and 3. Between 2 and 3. So what I have to do now? What is the slope of this one? I have to find. What is the slope of this one here? First point. What is first point? First coordinate here? 2, 2. Okay, this point is 2, 2. And this point is 3, 0. What is the slope of this one? y2 minus y1. So this is first point. This is first point. This is second point. 0 minus 2 divided by 3 minus 2. This is nothing but minus 2. Okay. So this is nothing but, I'm in normal notation, I am writing y minus y1 by x minus x1. Okay. What is y1 here? Y minus 2 divided by x minus 2. Okay. So what is this one I have? I have minus 2 here slope, and right hand side I have this expression. These two I am equating. Okay. Take this side. So minus 2x plus 4 equal to y minus 2. Okay. So what I am doing now? I have to express in terms y in terms of x. So this is nothing but y equal to minus 2x, y equal to minus 2x plus 2. This is what I have. Now let us consider the second part of the triangle, that is between 2 and 3 time units, between 2 and 3 time units, and it is called f2 of t. So it is a negative slope, straight line, and I can extend like this. And what is the slope of this one? I mean expression, I have to find the expression for this. Here I have the coordinate as 2, 2, and I have 3, 0. Second point. First point is 2 comma 2, second point is 3 comma 0. Now what I have to do, I have to find the, I will write the equation here. Y minus y1. What is y1? Y1 is 2. Then x minus x1. x1 means x minus 2. Then y2 minus y1. What is y2 minus y1? 0 minus 2. Similarly, I have x2 minus x1, that is 3 minus 2. Okay. So this is what I have. Now this is equal to minus 2. Okay. Now what is if I write the expression y minus 2 equal to minus 2x plus 4. Y equal to minus 2x plus 6. Okay. Y equal to minus 2x plus 6. So that is nothing but y equal to minus 2 x minus 3. Now what is my y variable? Y is nothing but f2 of t here on y axis, and x is nothing but t on x axis. Okay. So my variables are not really y and x, because we are familiar with x and y coordinates. I have used the x and y variables. So finally I have f2 as minus 2 multiplied by t minus 3. This is the expression for this. Okay. And this is not really f2, because it is the infinite straight line. When I will get f2, this is f2 between minus infinite to plus infinite. Okay, minus infinite to plus infinite. But what I want to get only segments of the straight line. So I have to capture only this part. So I have to multiply this function by another pulse. Okay. So there are to generate this pulse, I have to use two-step functions. Okay. So this pulse, how it is represented like this. What is this one? Unit step function delayed by 2. Okay. Then minus unit step function delayed by 3. So if I take this expression, because this I am not going to repeat again. So this is nothing but this pulse. Okay. The pulse is represented by this summation of two unit step functions. Okay. And this is the infinite straight line. This is infinite length straight line. Infinite length straight line. Okay. So when I multiply this and this, that means I am multiplying this infinite straight line with this pulse. Then what I will get? I will get a triangle like this. So this is nothing but f2 of t. Okay. So that is what I have done here. This is minus infinite straight line minus t of t minus 3 multiplied by the pulse. This is the pulse. This is the infinite straight line. When I multiply these two, I will get the f2. Okay. So this is nothing but f2. Now I have both f1 and f2. I have to combine this f1 and f2. So if I combine, I will get this full triangle. F1 is, I know already, F1 is represented like this by this expression. Then F2 is represented by this expression. Then I am adding these two. I will get, after substitution, I will get this. It's a long expression for the given function. Okay. So like that, you have to divide the composite shape. If any different shapes are there, they are regular shapes only, because you must be able to express in terms of equations. So that's why they will be regular shapes in general. And you have to decompose the total shape into different segments, different parts, different shapes. Then each shape you have to represent by relations. Again, you combine all these relations to find the final expression for the total figure. Okay. So that is so. So in this total process, the unit step function is taking a big role. Okay. Now, so there is another example in this slide. So I have a pulse between minus 1.5 to t equal to 0. Okay, how I will write this one? I can write this one as sum of two step functions. What is first step function? First step function, so actually this is the 0 axis. Okay, first step function must start at minus 1.5. Okay, this is minus 1.5. And second step function must start at t equal to 0. This is t equal to 0. So this is the second function. So first step function, second step function. So second step function is subtracted from the first function. So this area, this side, because it is existing from this side, this area and this area will get cancelled. Okay, so I am left over with this pulse which is existing between minus 1.5 to t equal to 0. Okay, so that's why you have this, because this is the t equal to 0 and you are advancing, because here delay is negative, minus 1.5. So if I substitute unit step of t minus minus 1.5. So it is t plus 1.5. And second function is starting at t equal to 0 step function, that is u of t. You subtract these two, then you will get a pulse. But the height of this pulse will, because both are unit step functions, the height of this one is only unity. So if I want to make it 2, I have to multiply this by 2, because the pulse, given pulse, has a amplitude of 2. Okay, so that's why you will get this. I think I have done sufficient exercise for this. Now let us take another function here. So this is basically again multiplication of two functions. One function is exponentially decaying, infinite curve like this. Another function is pulse between 0 and 3. Okay, so this my infinite decay function and pulse. If I multiply, I will get this one. I will get this given shape. This is the shape I want. Okay, so this shape is given by 2 e to the power of minus t by 2. So this is what you have, and multiplied by the pulse between 0 and 3. Okay, so that's why I will get f2 like this. And that is, first one is f1, this is f2. And if I combine these two, I have f1 here, I have f2 here. So I am getting another shape. So I am building the shape basically. Okay, so two different functions are given. If I have to make a total shape, I will get this. These are the f1 and f2. Sum of these two functions again, sum of this. Okay, I think I have given 3-4 examples. You must be comfortable by this time.
Like, share and subscribe. Hit the bell icon for more updates.